The system of onboard weighting and axle load control is designed to control the load of each axle in a vehicle to measure the weight of the cargo being transported. The number of sensors installed in a truck may be from 2 to 12, depending on the transport's configuration. Pressure sensors, displacement sensors, or any other sensors with analog output may be used. Weight parameters and axle load is read by the GPS tracker via RS-485 or CAN. For air suspension, difference 01 pressure sensor must be used, and for leaf spring suspension, difference 02 displacement sensors, or other compatible sensors. The number of sensors to be installed and its location primarily depends on the number of axles on vehicle, the number of lifting axles, and the type of suspension used. So, let's have a look at some examples of weighting systems configurators. First of all, we need to determine the number of axles in a vehicle. The nearby axles, trolleys, are considered as one conditional axis. You may find some examples in the picture. 3 conditional axes, 2 conditional axes, 4 conditional axes. After it is necessary to determine the minimum number of sensors to be installed, taking into account that on each conditional axis there must be installed at least one sensor. The exception is the tractor plus semi-trailer configuration, where no sensor is installed on the front axle. In this case, the load on the front axle is determined based on the load of the tractor's rear axle, on the position of the fifth wheel coupling, and the distance between the front and rear axles of the tractor. The minimum number of sensors in the weighting system imposes a number of restrictions related to the operation of the system. Firstly, the weight of the cargo and the load along the axis will be correctly displayed if the cargo in the vehicle's body is situated in such a way so that its center of gravity is in the middle between the right side of the vehicle's body and the left one. Secondly, in case of any lifting axles and trolleys, the load of the axle and the weight of the cargo when one of the axles is raised will be displayed not correctly. Let's determine the number of lifting axles. Per each lifting axle, there should be installed minimum one sensor. As the center of gravity of the cargo most often is not located in the middle with respect to the right or left sides of the vehicle's body, it is recommended to install 2 sensors per axle. The exception is the rear axle of the truck. Here, setting the sensor on each side is not very important, because the condition of the center of gravity is fulfilled. The fifth wheel is located in the middle relative to the right and left sides of the tractor. Also, there will be enough just one sensor in case if an air spring suspension, the right air spring and the left one have a common contour. Then there is no sense placing 2 sensors on each side. So, the optimal variant of the number of sensors for the vehicle configuration, 3-axle tractor plus 3-axle semi-trailer with 1 lifting axle is 5 pieces. Configuration 3-axle tractor or truck with 1 lifting axle and 2-axle semi-trailer with 1 lifting axle requires 6 sensors. Configuration 2-axle tractor or truck and 3-axle semi-trailer requires 3 sensors. Configuration 3-axle lorry without a lifting axle requires 4 sensors. The configuration of a 2-axle trailer requires 4 sensors. Systems installation. To install the system, you'll need an automotive toolkit, a laptop with software for the system setup installed, USB adapter Eurosens Destination 02, and truck scales. Also, to calibrate the system, it is necessary to measure the actual load when the truck is unloaded and loaded. That will require additional operations of loading and reloading. So, let's pay attention to the installation of axle-load sensors Eurosens Difference 01 and 02. Difference 01 sensor measures the pressure in the pneumatic elements of vehicle's pneumatic lines or its pneumatic circuit and transmits the data as a voltage signal to the system of onboard weighting. Output signal voltage from 0.25 to 3.8 volts. There are several ways to install pressure sensor into the air suspension. Pressure sensors installation in a factory supplied hold. Pressure sensor Difference 01 is installed in M16 1.5 hole without continuing the pneumatic circuit. To install the sensor by this scheme, the elements in the sensors kit is enough. The electric connection of the sensor to difference T is done with the help of a cable with connectors at both ends. It is enough to plug it into a wall outlet of difference T. Displacement sensor Eurosens Difference 02 is designed to determine the axle load or cargo weight in vehicles with leaf suspension system by measuring the distance from the chassis to the axle. Output signal voltage from 1.5 to 3.5. To install properly Eurosens Difference 02, it is necessary to find out the suspension travel from a fully loaded to an empty state. It is recommended to install the sensor so that the angular movement of its level is maximum when the vehicle is loaded from empty to full. At the same time, it is necessary to exclude the possible excess of limiting angles from -40 to 40 degrees. Based on this, the mounting location of the sensor should be selected as well as the length of the connecting levelers from the mounting kit. In case the spring works on the two axles at the same time, additional rod should be used. In the middle, it will be connected with a vertical measuring rod. So, we measure the average vertical displacement of the two axles. After the sensor is installed, it is connected via the cable with the system's controller Eurosens Difference T. When all the sensors are connected, we should connect all systems elements in one. The free connector of the Difference T unit must be closed with a cable plug, setting up the weighting system. When you first start the program, a login window will appear. To access the program, you need to click on the registration link. A registration form will open in PDF format, which must be filled out and sent to GSK Mechatronics. After you are provided with the ID and password, you must fill in the appropriate fields in the box at the entrance and click on the login button. A check mark that is in front of Remember means that the next time you start the program, the ID and password will be automatically filled with the latest data. After entering the program, you can select the interface language in the language menu. First of all, you need to connect the service adapter Eurosens Destination 02 to your notebook using a USB cable. Use the key set on Destination 02 to transfer the adapter to work with the RS485 interface, and your device should appear in the ports COM and LPT type in the device manager. We establish connection with the adapter. For this, open the Settings COM Port Settings menu. In the window that appears, enter the COM port number and data rate, which should be selected to be 19.200 bound. A successful connection of the program with the Eurosens Destination 02 adapter is indicated by the status bar. To establish a connection with the weighting system, it is necessary, instead of Eurosens display RS, which is connected to Eurosens T cable, to connect Eurosens destination 02. In the type of truck drop-down list in the Set Profile window, select the appropriate configuration. Enter the parameters indicated by the red rectangle. If you choose another type of truck, the list of required parameters will change. The next step is to set up the location of the sensors in the system, enter the serial numbers in accordance with the sensor's location in a particular place or mode of transport. For this, open the corresponding window in Settings, Location of sensors in the system. Select the location and number of sensors on the axle for your specific vehicle configuration. Then, in the addressing table in the serial number column, enter the serial numbers of Eurosens Difference T configuration blocks according to the location and click on the Setup Addresses and Load Parameters button. In case of successful setting of addresses and loading of parameters, the corresponding dialog box will be displayed. In case of an error in setting of addressing and loading of parameters, an error message will be displayed. This can occur if not all configuration blocks are correctly connected or serial numbers are entered incorrectly. It should be noted that if there are no lifting axles in the truck and two sensors are placed, one for each side, then the following options for setting the location of the sensors are identical in the truck. It is assumed that all airbags, in the case of air spring suspension, on the sides have a common circuit and there is no difference in which of the pillows to put a pressure sensor. A few more customization options that will be identical. You can make sure that all the sensors in the system are connected and in good condition by opening the Detector Reading window in the Test, Detector Readings menu, or by looking at the status bar at the bottom of the main configuration window. System calibration. Consider the case, truck-tractor with a semi-trailer. Calibration will require bed scales, as mentioned above, to measure the actual loads of the vehicle as well as the ability to load the cargo into the vehicle, preferably before full loading. We weight the trailer by axle. Open the System Calibration window and enter the load values along the axis taken from the bed scales for actual weighting. The load fields of the semi-trailer axles may contain 0 at this step. Next, press the Calibrate button. We respond positively to the request for clearing the calibration tables of the sensors. After the first calibration step has been completed, 2 records should be displayed in the calibration tables of the sensors located on the towing vehicle. You can view the calibration table by sensors by opening a window in the Setting, Calibrate, Tear Individual Sensor window. Step 2. We hook up the empty semi-trailer to the trailer. We weight the road train by axle. In the System Calibration window, select the next step, Empty Road Train, Step 2, and enter the loads along the axis. Then press the button Calibrate. After completing Step 2, another entry should be added to the calibration tables of the sensors on the trailer. Calibration tables of sensors on a semi-trailer should contain 2 entries each. Please note that all system sensors must be connected. Step 3. We load the semi-trailer. We weight the road train with cargo. On the right in the window, select the Laden Road Train, Step 3, and enter the loads along the axis. Then press the button Calibrate. Step 3 can be repeated if the semi-trailer is loaded gradually with increasing load. In this case, One calibration record will be added to all calibration tables, and the measurement accuracy will increase. When recording the last point, set Last Record. After all the steps are completed, you must click the Load Data to Sensors in the System Calibration window. After loading the data into the sensors, a dialog box about the success of the operation should be displayed. Fill in the remaining data in the Set Profile window. Next, you need to open the Settings, Location of Sensors in the system, and once again click the button Configure Addresses and load the parameters. After this, the adjustment and calibration of the weighting system and load control can be considered complete. After the weighting system is configured and calibrated, you can view the axle loads and the load weight in real time. For this, open the Test Axis Loads Vehicle. Connecting the display. The calculation of the cargo weight and the image on the driver's display is carried out by Eurosens Display RS. To translate Eurosens Display RS into this mode of operation, it is necessary to load the firmware into it to work with the weighting system. After updating the firmware, Eurosens Display RS does not require any settings.